Okay, everybody, let's move on to the next lesson here with angles. Now, this is one of those things where you're going to recognize this very much. It's called parallel lines with transversals, and I guarantee you've seen this before. It's one of those things where it's deceivingly easy, but it's funny at the same time. It's one of those things that's so easy that's almost kind of like your brain gets a little bit mixed up sometimes. So I'm going to try my best here to make this as easy as I can and as clear as I can. And this is also one of those things where the more you do it, the quicker you're going to get at this. And I think maybe the trickiest part of this would be the vocabulary that kind of catches people as to how to explain what they're doing. Anyway, I'm going to move on. This is one of those things I will give you practice, and then you will be able to, I think your brain will figure this out pretty darn quick. And like I said, you have certainly done this before in earlier grades. What we're looking at here today, it's called transversals of parallel lines. Well, if you look at this example, the two blue lines are parallel lines. That means they run straight side by side next to each other. They'll never get closer, never get further away. The transversal is a line that runs through the parallel lines, obviously not straight, like perpendicular. What I mean is it'll never be like this, everybody. It'll never be like, if I could draw, pretend those are perfect parallel lines. The transversal is never going to go straight through it perfect, because if it did, each of these would be 90-degree angles. Okay, so that's never going to happen at least in the math that I'm going to teach you, and I haven't come across that. So the whole point here is when you have these two parallel lines in a transversal, it creates, well, as you can see, I count 8 angles right there, A, B, C, D, E, F, G. And the thing is, of course, if this was given to you and you had a real life example, sure, you could take out a protractor and you could measure everything. But that's not the most efficient way. There actually there are relationships here that you can memorize and understand and use those to your advantage to make this quite a bit easier. So, as far as math calculation, there's not too much going on here. It's more about understanding the terminology, understanding the relationships, and simply providing the answer. So we'll move along here. I would say here, though, everybody, please feel free to, you can stop this anytime, obviously, and just kind of take a moment to ensure that you have each of these categories down pat. Okay, so the first one is called vertically opposite angles. Vertical angles are opposite from one another. And all I mean here is, I don't care where you are in this figure. By opposite, it means look at A. Right on the other side is D. They are vertically opposite, up and down. Think of it as up and down. C and B are vertically opposite, up, down. E and H are vertically opposite. G and F are vertically opposite. And here is the deal. All you need to know is if you know one of them, you know the other. So for example, A is exactly the same as D. B is exactly the same as C. So if this was a real life, like a question you were given, if this angle right here was 35, you know for sure that this angle here is 35, 100%, okay? You know that. I'll just give you, if this one was 57, for example, you would know this one would be 57. So vertically opposite angles are essentially are angles that are up and down from each other, okay? They're just equal. You can kind of, no big calculations. Just if you know that relationship, you can figure this out, okay? I guess it's on this page right here, it says, what did it say here? We probably should do this. It says, A and D, they are vertically opposite. I get that. What are the other 3 pairs of vertically opposite angles? Well, angle B and angle C, that would be another pair. So that's the one they gave us. That's the other one. The other one would be angle E and angle H. And the other one would be angle G and angle F. Okay, and all you remember, whatever the value of A is or D, vice versa, they're exactly the same. So of course, if you're given this type of thing in a question, you can apply this strategy and you'll know a lot of angles. Okay, so that's vertically opposite. You want to kind of commit that terminology to your head, to your memory, because here's what's going to happen. I understand that the math here, the understanding is easy, but in some of these questions, you're going to have to say which rule did you use, and you'll have to say I used the vertically opposite angles property. It's not enough to just say what the measurement is. You have to say which of these rules you've applied. Okay, we're going to move on. The next one is corresponding angles. Okay, so again, this is one now where the terminology comes into play, and you're going to have to kind of really be careful with this and commit this to memory. So a corresponding angle. These occupy the same position at a different intersection. I think this all makes sense. I mean, although we're not measuring anything, I think we all would agree, if we consider this ABCD intersection, I think it's pretty clear that all of the angles down here are exactly the same. So it says here, so corresponding angles. These occupy the same position at different intersections. So for example, so angle A would be equal to angle E. That's one of them. Another one would be, let's see here, angle B would be equal to angle F, and then we could go angle C would be equal to angle G, and angle D would be equal to angle H. So of course, if you knew the measurement of one of these, you could figure out the other. For example, if, I'll just kind of erase this for a second, if this measurement right here was, let's just say that is, I mean, it can be anything, let's just say 105, I mean, who knows? You know without doing any math or any measuring that angle C must also be 105 degrees. So corresponding angles. The angles are the same, they're just at the same spot but in different intersections. Okay, so commit that to your memory, and we're going to move on. So we have two situations, we have two, I guess, rules right now that we can use. And so we have vertically opposite and corresponding. Okay, we're going to move on. The next one are alternate interior angles. Okay, so now this is where, we're getting into now some terminology, and there certainly is room here to, have some confusion creep in. So you have to find a way to commit these terms to your memory. I will tell you how this works out, but you're going to have to find a way here to really commit this, to really understand it. Alternate interior angles. If you look at angle C and angle F, okay? So here is the rule. They are both, so I'll just kind of highlight this. So here is C and here is F, okay? So if we follow the definition, they are inside of the parallel lines, that makes sense, and they are on opposite sides of the transversal. So to be an alternate interior angle, here are the rules. There's two of them. One, you must be inside the parallel lines. Run out of room. Rule 2 is that you must be on opposite sides of transversal. So that means if angle C, let's just pretend, was 120 degrees, you know right away that angle F is also 120 degrees. Now there is another pair that I guess satisfies this condition. So we're looking for another pair of angles that are both inside of the parallel lines and on opposite sides of the transversal. I'll change, I know everyone knows what one it is, but I'll just change color, and that would be D and E. So angle D and angle E are also alternate interior angles. Now I really hope that you're watching this. I hope you're pausing. I hope you're re-watching, because you're going to you have to really understand this. And of course, you know that there will be practice on this at the end. I mean, that's how you're really going to figure this out. But it's not enough to sit there and say, I got it. Do you know what the terminology means? If someone said to you, hey, explain to me what alternate interior angles are, could you do that? If someone said to you, hey, what are corresponding angles? Could you do that? Okay, that's kind of the level you're trying to get to here. It's not enough to say, oh, the angles are both 33. You have to be able to state the rule that you're using. Okay, we're going to move on to the next one here. Okay, and this should be just about to the end here. So this one is called alternate interior angles. Or sorry, let me change the way I read here. Alternate exterior angles. So in this deal here, your angles are on the outside of the parallel lines and on opposite sides of the transversal. So think of it. Exterior means outside. Heck, if you want me to go back and show you this here, this was called alternate interior angles. Interior means inside. I guess that could be your hint. If it says alternate interior angles, you're inside the parallel lines. If you go back here, this one says alternate exterior angles. So right now that means outside the parallel lines. That would be your hint to memorize this if you so choose. So it says here that the rules are you must be, number one, outside parallel lines. That's the first rule. And that comes from the word exterior. That's your memory trick. And number two, they have to be on opposite sides of transversal. So if you satisfy those conditions, you should be good to go. So if you look at this example, then I'll just go to orange or something. So we need to find our pairs here. So if we look at angle A is outside of the parallel lines. It's on the exterior. Its alternate exterior angle, its match would be, go down the transversal on the opposite side, it would be H. We know that H works because it is on the outside of the parallels and it is on the other side of the transversal. The other pair of angles that would satisfy this condition would be angle B, and that would equal angle G. Because if you look at angle B, which is right here, it is on the exterior or outside of the parallel lines. If we go down the transversal, we now come outside of the parallel to the exterior, and we have to flip to the other side of the transversal, and that would be G. Okay? So what we've looked at here is we have four rules or four terms that we need to know. Okay? So I would very much encourage you to stop this lesson, to pause it right now, to go back, look at each of these again, and truly ask yourself, do you get it? If you can't say what the terms are, explain them to someone else, I would not say that you thoroughly know this. You have got to be able to understand what each of these means, okay? So in my mind, this is where we would stop the video. We would really do some, reflection here and figure this out. I'm going to move on and show you some examples. So we'll go from there, and this will help you understand to the level you kind of need to know these rules at. So just some more help for you here. Okay, so let's see if we can answer some of these questions. It says here, how many angles do we have? And you can see here, oh, this is interesting. They flip the transversal the other direction. So let's see here. I'm going to number these. This will be 1, 2, 3, 4, 5. I guess I'll go this way. 6, and then 7, and then 8. Okay, so I guess obviously here we have 8 angles. Boom, we've done that. So we've check marked that, named them using numbers. We have done that. Perfect. It says which pairs are alternate exterior angles. Well, that's not too bad. If we have alternate exterior angles, well, that's not too bad, because remember, exterior means outside. That's your hint. So we need to look outside of the parallel lines and find angles on opposite side of the transversal. So in my opinion, if you look here at number 1, it is on the outside of the parallel lines. If we travel down the transversal and go to the other side, it's angle 8. So we know that angle 1 is the exact same as angle 8. This will come into play because eventually you'll be told, hey, this angle is 67 degrees. Well, then you would know right away that angle 8 is also 67 degrees. Okay, so I'll get rid of that. What else do they want? Oh, I guess they wanted to know the other pair of alternate exterior angles. I haven't done that yet. The other angle on the exterior of the parallel lines would be angle 2. To find its match, we would travel down the transversal and come out of the parallel lines and flip to the other side, and that would be angle 7. So we've done now that dot. Now we have the alternate interior angles, and that's going to be, if you remember the definition here, it said those have to be inside of the parallel lines and on separate sides of the transversal. So if we look here at, we're going to look, remember we're inside the parallel lines now. Number 3, well, all you have to do is travel down the transversal, but stay inside the parallel lines and just flip to the other side. So we know that angle 3 is the exact same as angle 6. The other one here we could consider would be inside the parallel lines, because interior would be angle 4. Travel down the transversal, but not outside the parallel lines, and that would be angle 4 is equal to angle 6. Okay? That's basically, that would be my thought process, what's going on in my head. Again, pause this, understand it, rewatch it. One thing I would do if you were, in front of me in a classroom, I actually would probably have you do this on your own. I would say, like, could you replicate this and answer this on a piece of paper? Could you copy down that transversal right now and the 2 parallel lines? Could you do this activity? Could you answer those questions just like I did? Okay, and that's how you're going to know if you truly understand this. Okay, and this is, of course, this is the same thing. I'm going to skip by this, but you by all means can try it if you want, but it's the exact same thing. Sorry, I had a duplicate side in there. Okay, there's only one last thing here that I just might want to tell you about. This is not something that you necessarily need to remember or name or have vocabulary for, but it does come into play from time to time. I want to focus there on the A and B. Sometimes you'll be given either A or B. Okay, no big deal. But I want to show you, if I just zoom in like this, I'm just going to draw a part of it. And it's going to shoot up like this. Okay, and this is A and this is B. And there is a relationship here, everybody, okay? Obviously, what I always do, remember, what kind of angle is this? This is a straight angle because we can draw a half circle. It's a straight line. So if you took this angle and this angle, they are a straight angle. So what do they have to add up to? They have to add up to 180 degrees. Okay? They must equal 180 degrees. Therefore, if you know one of these values, you can figure out the other. So, if we just go down here, if I were to show you this, let's pretend that A was 120 degrees, and they'll say to you sometimes, well, what's angle B? Well, all you'd have to do is go 180 minus 120, which of course is 60, and that would give you this angle right here. That's just a little useful trick that comes in from time to time. It is beneficial to draw that semicircle. I mean, again, I'll show it to you. I'd even do it sideways. This, from here to here, of course, is a straight angle, 180 degrees. I draw that semicircle. Now I know if I had H, I could figure out F, or vice versa. I could also use that, let's see, where else? I could do it anywhere. If I knew, let's see, between A and C, that was a straight angle, 180 degrees. Draw your semicircle, use one to figure out the other. Just a little rule that'll help you get by, okay? Okay, so it says here, solve for all unknown angles using the properties. Well, oh my goodness. It's like, well, where do you start here? You have so much. As far as I can tell, if you remember from a couple slides ago, there are 8 angles here that we don't know. So what I'm going to do is I'm going to label the ones that we don't know. This is 1, 2, 3, 4, 5, 6, 7. Because there's not 8 because we already know one of them. So what we're going to do is we're going to use the properties here to figure these out. I'm going to start with angle 2. I know that angle 2 is also 135 degrees. Why do I know that? Well, there was a piece of terminology that we learned. They're kind of up and down or exactly opposite from each other. So what you would have to do is you'd say it's 135 degrees, and the rule is the vertically opposite rule. Done. Okay? Now, what else could we use here? Well, you can see there are many. Once you get the hang of this, you're going to see that the pattern that I follow may not be the pattern that you follow. There's different ways of doing this. End of the day, just because I say it's this rule, let me reword that, sorry. There are different paths that we could take to the exact same answer. So just because I figure it out one way doesn't mean there isn't a second way of doing this. And both of them would be perfectly right as long as you use the correct terminology. I'm going to figure out now, heck, I'm going to go for number 6. Number 6. So I'm just going to, I'm just going to scribble these out for I kind of know where I'm at here. So number 6, and actually, no, that's stupid. I'm going to go like this. I'm going to put in that this is 135. Now, number 6 there, we can use the alternate. Oh, sorry. Yikes. I should use a number first. It's 135 degrees. And why is that? That is the rule, the alternate exterior angle rule. Okay, there you go. So if I'm going to erase this now, this would now be 135 degrees. Good. Now look at that, everybody. We now know this one's 135. Couldn't we figure out angle 5 now? Angle 5 would be 135 degrees. Which rule states that? That would be the vertically opposite rule. Good. Things are kind of moving along here now. And again, let me be the first one to admit, if we had 30 people in a class and everyone had to do this activity, people wouldn't follow the same process that I am, and that's totally fine, as long as the rule that you use and the method is correct. Okay, where else can we go here right now? What else could we do? Okay, for me personally, what we're missing now is 1, 3, 4, and 7. I'm actually going to revert back right now, just one slide here, to this rule. Remember these adjacent angles? And what did they equal? Those are the ones that equaled 180. So what I'm going to do is I'm going to figure out number 1. Angle 1 would be 180 minus 135. That's because, everybody, if you look, from here to here is what shape? That's a semicircle, which is 180 degrees. So all you have to do is take your calculator, go 180 minus 135. Once we have this, we have the key to the entire question here. It is 45 degrees. That's it. And I guess the rule that we used was adjacent angles. Okay. So I'm going to get rid of this mess here. I'm just going to rewrite this because we now know that this is 45 degrees. Let's see. Let's do number 3 now. I think we know what angle 3 is going to be. Angle 3 will also be 45 degrees. Which rule? That's the vertically opposite rule. Okay, so I'm going to get rid of number 3 because that one's going to be 45. And now, well, I don't know, let's figure out, it's your pick. I see 2 or 3 ways of doing this. It truly doesn't matter. I'm going to do number 4. I'm going to do it in a little bit of a different way. I'm not saying this is the only way. But number 4, I'm going to use the alternate interior rule, because the alternate interior rule says stay inside of the parallel lines, come down the transversal, and flip. So I know the alternate interior angle of the measurement number 4 is also 45 degrees. And finally, and thank goodness I'm running out of room here, this is 45. The last strategy is you have to figure out number 7. There's numerous ways to figure this out. You could use alternate interior, you could use adjacent angles, you could use vertically opposite. It's totally up to you. I'll say angle 7, I'll go vertically opposite, I like that one. And we know that it is going to be 45 degrees. Now look, I want to say this one last time. If you have someone else sitting next to you, They might say, I wouldn't do it that way. Or another teacher might come by you and say, well, I wouldn't do it that way. And that's okay. I could redo this right now in numerous other ways. All I care about is, can you figure out the measurements and can you apply the correct rule? And that's all that matters. So there are other ways that you could figure out all these numbers using those rules correctly. Okay, so it's going to be up to the person that, who marks your work here, who checks this out, to ensure that you're using the rules properly. Okay, and you need to figure this out too. You need to make sure you're using it properly, and do a lot of practice on this. So please, you may want to pause this video. You may want to rewatch it 2 or 3 times. My advice would be to take something like this, draw a blank version of it on a piece of paper, take the 135 or make it 125, it doesn't matter, and see if you can name all the other angles or figure out their value using proper ruling methods. Okay? And if you really want to go for it, you would try to accomplish this activity using different rules each time. That would certainly change the way this looks. Anyway, I need to move on. Now what we'll do is I'll just, we'll do a couple of examples here to kind of, see where we're at. Okay, so what can we figure out here? It looks like they've given us here, it says in the diagram below, L1 is parallel to L2. State the measures of the indicated angles and explain your reasoning. So it looks like they want us to figure out angles 1, 2, 3, and 4. Well, okay, we can do that. That's not a big deal. Let's start with, again, you could start anywhere you want. There are numerous ways of doing this. I'm going to go with angle 2. I'm going to go angle 2 because I know if you go right here, if you made a connection from there to there, those are adjacent angles. So adjacent angles, that's the deal with, you see a semicircle, you would go 180 minus 118, and that would give you 180 minus 118. I always like to do the math in here if I don't make a simple mistake. It's 62 degrees. Perfect. Oh, and the ruling there is adjacent angles. Okay, perfect. Now they want us to figure out number 3 and 4. I mean, I'm going in any order here. It truly doesn't matter. I'm going to figure out angle 4. Angle 4, I'm going to use, what can I use here? Actually, pardon me, I'm sorry. I'm going to use I'm going to figure out number, it really doesn't matter at all, actually. You know what I'm going to use here is one that we haven't looked at for quite a bit here. I'm going to use the corresponding angle rule. Right, actually, I'm glad I'm doing this. If you remember back to your corresponding angle rule, that's where it stated that if you have the same position at different intersections, they are equal. So what I mean here is, if I were to draw a mini version of this question right here, you see, this right here is 118. This right here is 62. This is one of our intersections. Well, isn't this an intersection as well? It's just a different intersection, but on the same transversal line. So doesn't that mean then that angle 4 would be 62 and angle 3 would be 118? It does. So I'm going to say here angle 3 equals 118 degrees, and I'm going to say angle 4 is equal to 62 degrees, and that's going to be due to the corresponding angle or corresponding angles. Okay, see, I'm actually glad that I went that route because we haven't used that one yet in any of our explanations. So that's actually a pretty good thing to do. Okay, so the only one that we have left is number 1, and I'm sitting here thinking about this, and there are a few ways to figure this out. Again, I don't want this to become overwhelming or confusing. It's simply just whatever your brain will catch on to this, and you can apply any rule or logic that works here. I'm going to tell you what I'm going to do here. You see, the 71 right here, we know that this is 71 degrees. Now what I'm going to do is I'm actually going to draw a straight angle from here to here. That is now 180 degrees. Now, although it's not required for the question, Could we figure out this angle? Well, of course we could. We'd go 180, take away 71, because they are, okay, because that's a straight angle. So 180 minus 71 is 109 degrees. Now, the reason that's important, and allow me just to write that in here, is I think we can apply now the corresponding angle rule again. What I mean is, here's one intersection. Is this not another intersection? We're along the same transversal parallel lines. So now I know that angle 1 is 109 degrees because of corresponding angles. Now again, let me be the first one to state, there are likely numerous ways of figuring this out. These are just the rules that I chose to use in these examples. You may choose something different. You may choose to do a different order. That's up to you. At the end, like I said, you have to have the right numerical values, and the ruling that you use has to be correct. All right, let's move on. All right, it says name the relationship between the indicated pair of angles. Okay, well, we can do that. Angle 3 and angle 5. Well, angle 3 and angle 5 are both inside of the parallel line, so that's going to be alternate interior angles. Remember, they are interior because they're inside the parallel lines, and they are on the opposite sides of the transversal. Okay, now 4 and 5 here. I'm going to move by that one just for a second. Angle 1 and angle 3. So those are going to be vertically opposite angles. And number 2 and number 6. Okay, so again, I'm going to use the corresponding angle rule for that one. Corresponding angle, I'm just going to try to minimize my writing here. Corresponding angle rule, because you can see we have two intersections and they essentially occupy the same spot in both of those intersections. Finally, you know what, I think here what I'm going to do is I'm actually going to not worry about 4 and 5 right now. We have not necessarily clarified the ruling for that. It doesn't mean you couldn't figure it out. You very easily can, and you very easily will. I'm not going to add in anything else at this point in time. So what you would do is if you needed to figure out 4 and 5, I would figure out everything else first, and once you have some of those rules, you could figure that out. I don't feel like adding another rule or piece of terminology to this, so I'm just going to skip that out for right now. Okay, what do we have here now? It says in the diagram below, length 1 and length 2 are parallel. Determine the measures of the angles. Okay, fine, we can do that. And we'll go from there. Okay, really it's up to us where we feel like starting here. It truly doesn't matter. So let's go with, I don't know, let's do angle 4 first. Angle 4. Well, that 62 and that 4 are right, opposite of each other. That's the vertically opposite rule. Well, that would make number 4, or angle 4 would be 62 degrees. Okay, let me just erase this here. I'm going to put, if I can, just go 62. That's nice. Let's see here. We could figure out right now, we could do number 2, I suppose. Number 2, or angle 2 as it is, we could simply use, it doesn't matter where we go from, I'm going to go from down here. We have that straight angle rule, the semicircle 180. So all you'd have to do would go, you just simply go 180 minus 62, and that will give you the measurement there. So 180 minus 62 is 118 degrees. So if I erase that now, so this one here is 118 degrees, this was 62. And don't get me wrong, I know that there are other ways of doing this. That's just kind of the strategy that we chose for right now. Okay, now we're going to look at angle 3. Angle 3 is a little bit, maybe a little bit more tricky to look at, except what I'd ask you to do is consider this intersection. Okay, so remember these two lines here are parallel. This is your transversal. This is your intersection. Remember we have the corresponding rules. So you see angle 3 is exactly in the same position as angle 4. So you have to kind of continue this line here. So here's your intersection. Remember, if you have a transversal going through two parallel lines, the corresponding angles rule says if you're at the same position at different intersections, you are equal. Therefore, we know that angle 3 is equal to angle 4, which is 62 degrees. And the ruling there is the corresponding angle rule. So you can see here how you have to be a little bit creative. And again, I'll just kind of show you where I got that from. These two lines here, I'm just going to draw a smaller version. These two lines are parallel. And what the question's given you essentially is this. And we know number 4. Number 4 was 62 degrees. Well, what you could do is you could extend this transversal down. Now you have an intersection here and you have an intersection here. This is in the same position as that. And that's how we figured out angle 3 by using angle 4. So you can see here you have to be a little bit creative sometimes to put everything together. Finally, we'll look at number 1, and I have to be honest here, I'm hesitant to even go over how to do number 1. I'm very worried because I'm not in front of you here. I don't want anything to become too messy. One thing I'd like you to look at here is I'm going to redraw this just a little bit. So here is our straight line. And what we have essentially, everyone, here is we have a line like this. That's L1 and this is L2. So here's the deal. L1 and L2, they are parallel. This line is your transversal. It is cutting through those lines. What I'm going to do is I'm going to extend L1 and L2 just a little bit. So what we know here, everyone, is this is 67 degrees. And what we want is angle number 1, which is right there. Well, what I would do essentially is, if you look on the right-hand side, remember this is our intersection, okay? We could use vertically opposite. We know that this would be 67 right here. What if we figured out this one? Those would be your angles that are your adjacent angles. So what you would do is you would go 180 minus 67, and that gives you 113 degrees. See, now that's the trick to this question, because now that we know this one, we know number 1 because of corresponding angles. So angle 1 is also 113 degrees with corresponding angles. I guess what we've seen here in this question is sometimes you have to look beyond the diagram. You have to draw extra intersections and go from there. So it's a little bit tricky, and I know that. Again, if you want to see, I hope that makes sense what I did there. I'm really kind of back and forth on whether I should do this. But remember, I'm just going to get rid of these. The point is that you have to be a little bit creative and have a little bit of problem solving in you. What you had to realize is that these two lines are parallel. This is crossing through them. Even though it ends, you could go like this if you so choose. So now we have a transversal with two parallel lines. Now, this is 67, which means, you don't even need to do that. If you look from here to here, that's a semicircle. So you could now figure out this angle by going 180 minus 67, which is 113 degrees. Now, this is an intersection. This is an intersection along the same transversal. Angle 1 occupies the same spot as that 113. That's where we can apply the corresponding angle rule. Therefore, angle 1 is 113 degrees. I'm not going to admit that that's overly easy. I hope that's making sense. Please, take a moment here to rewatch this a few times. Really figure that one out. Okay, and maybe I'll just do one more here and then life will be good. It says here to figure out on trapezoid, whatever, PS is parallel to QR. Okay, fine. What are the measures of angle 1 and angle 2? Okay, well, this is not too bad. I'm actually going to figure out angle 2 first. You know what? No, it doesn't even matter. There's one little trick here that maybe you haven't come across yet. And I just want you could feel free just to memorize. You should memorize this. In every triangle. Whoa, I can't even spell triangle. In every triangle, there is 180 degrees. So if you take all of your angles together in any triangle, you have 180 degrees. Okay? This question really is just testing to see if you know that. So, look, this is the triangle that has angle 1 in it. And this one is 133, 133, this is 24. If you ever want to figure out a missing angle in a triangle, all you have to do is go 180 and subtract the other two angles. So subtract 133, subtract 24, and that will give you the angle of number 1. So you go 180, take away 133, minus 24. We know that angle 1 is 23 degrees. No big deal. If you want to figure out number 2, number 2 is in the lower triangle, which looks like this. This has that little box, so this is 90 degrees. This is 67. Same rule applies, it's a triangle. So all you have to do is go 180, take away 90, take away 67, and you'll get your answer. So 180, that gives you 23 degrees again. Okay, so angle 2 is 23 degrees. Now, yes, you could use other ways of doing this. I obviously understand that these are parallel lines of the trapezoid, and we could have used some different rules here, but anyway, that's just one strategy that came to my mind. If you want to see another way, by all means, I will show you that right now. Okay, one thing you could do here is you could think to yourself, let's figure out angle 1 first. So to figure out angle 1, all you had to do was go 180, take away 133, take away 24. And I believe that gave us 23 degrees. So this right here is 23 degrees. And if you want to go in line with our lesson, remember this line is parallel to this line. And so what would we call this line that cuts through? That would be the transversal. Okay? Well, so let me just draw this out. There's our parallel. So look at that 23. Look at that 23. That is on the inside of the parallel lines. So is number 2. It's just on the alternate side of the transversal. So we know that angle 2 would also be 23 degrees. Why? Because of the alternate interior angle rule. So you can see that there are some different strategies going on here. Even though I'm teaching this lesson, I didn't even apply any of the terminology. But I do see what's going on here. You just have to sometimes be a little bit creative. So again, I think the whole point here is looking at this and trying to extend on the drawing. So you would just simply say, okay, well, this line and this line are parallel. So I'm going to go parallel, parallel. This is the transversal. If you know that this is 23 degrees, can we not apply one of our rules? If we stay inside of the parallel lines and go to the opposite side of the transversal, we have number 2. Because angle 1 equals angle 2 due to the interior alternate interior angle rule. Anyway, I'm going to give you some practice with all these. Please ensure that you know these terms, that you can show your work and you can explain the numbers that you get. And again, please don't get discouraged. Someone next to you might use different rules. The point is, as long as you use a correct rule in the correct order, you will be fine. So that means someone sitting next to you might look at a problem and do it in a different order. They might even state some different rules. But it is possible to have the same number but use different rules to get there. Okay, we will try some problems.